All right, great. Welcome, everyone. My name is Robin McDaniel. Today, I would like to talk with you about artificial intelligence and what I call the missing middle in AI usage. This is a space between using AI casually and using it as a rigorous research partner. This session examines AI in research, scholarship, and creative practice, with particular attention to how it can support scholarly productivity. And you may have to read a little bit as I'm speaking. I'm not speaking from the PowerPoint, so you might want to read a little bit as I go along. And just let me know if you need a minute. So what is the missing middle? Artificial Intelligence 101 represents basic prompting at entry level. You have limited control over results. You write a prompt and hope the output meets your needs. At the other end of the spectrum, AI 401 represents professional level work with a high technical barrier. This includes building APIs or application programming interfaces through coding or other technical methods. The missing middle lies between these two extremes and involves learning to use AI in a structured, collaborative way to produce more reliable outcomes. So why should we care about learning how to use artificial intelligence effectively? The answer begins with usage data. A recent Pew Research study showed that more than half of teens and adults under 30 already use AI to find information, and about 1 in 10 teens rely on it for all of their schoolwork. Some studies suggest that incorrect usage can reduce productivity. In contrast, research from MIT shows that using AI correctly can improve performance. The difference may lie in whether users develop the knowledge and strategies needed to work with AI successfully. Regardless, the overall trajectory is clear. AI use is growing. We can no longer ignore its presence in research and professional life. The real question is not whether AI will be used, but whether we can learn to use it efficiently. Many people have tried AI and felt frustrated. A major reason for disengagement is the experience of confident errors. AI can produce responses that sound authoritative but are incorrect or fabricated. In research contexts, users often found that verifying AI output required more effort than completing the work manually. As a result, many concluded that using AI was not efficient and chose to abandon it. The disconnect may not be the AI itself, but the lack of training on correct usage. The challenge is not that AI is ineffective, but that it is uneven. AI performs very well on some tasks and poorly on others. The pattern is described as the jagged frontier and highlights how AI performance varies across tasks. AI can be highly useful when with clearly defined boundaries, but it may become unreliable or even harmful when pushed beyond those limits. For example, AI can produce strong literature summaries, but may fabricate or hallucinate citations. It can assist with coding tasks, such as building an API, yet struggle with theoretical interpretation. AI retrieves and organizes information efficiently, but it does not interpret meaning in the same way human researchers do. Many problems may arise when users rely on AI without applying human judgment. On this slide, you can see examples of current AI strengths and weaknesses. Researchers describe AI as inconsistently brilliant because its capabilities, as I said before, are uneven. You can see in the table what AI can and cannot do within the frontier. A key challenge for higher education is that the jagged frontier is constantly shifting. Tasks that were unreliable in the past may become dependable over time. We must ask whether a task falls within the area of high performance or within the zone of risk. In academic contexts, particular caution is required when tasks demand complete factual accuracy, such as citation verification, because it will make it up. The key takeaway here, boundary recognition is a core research skill. Knowing how and when to use AI is essential. So we're going to cover some of the AI skills and concepts on these slides that lie in the missing middle. Skill 1 is context assembly. Users often rely on a naked prompt, a question without sufficient background. In research settings, this may produce generic or inaccurate results. Context assembly creates a controlled environment that improves reliability. Think of context assembly not as asking a single question, but as building a temporary expert workspace for the AI. So how do you do this? First, you establish the foundation by providing the AI with your specific data or source material. This shifts the task from summarizing general knowledge to analyzing your data set. Next, you add a framework by assigning a professional role or persona, such as peer reviewer or methodologist. Then define boundaries by setting clear constraints and rules, such as limiting timeframes or excluding variables. And finally, apply the roof through structured output requirements that shape how results are presented. So you ask it whether or not you want to present the material in a table or Word document or whatever it might be. When you submit a well-assembled prompt, you're not simply asking a question, you're briefing a specialized assistant with clear expectations and appropriate resources. Notice the contrast shown on the slide. A naked prompt may provide a general response, but it's not reliable enough for research decisions. Without sufficient context, the AI may fill gaps with inaccurate or fabricated information. An assembled prompt creates a controlled environment by providing specific transcripts and assigning a professional role, such as a peer reviewer. You guide the AI towards more focused and academically rigorous output. Even with strong assembly, human quality judgment does remain essential. AI increases speed and scale, but validation and interpretation remain human responsibilities. The next skill we will look at is quality judgment. This is where human expertise becomes essential. It guides decisions about when and how AI should be used in research, especially within specialized domains. Researchers must audit AI output with the same rigor used when reviewing a student's thesis. This involves checking whether interpretations align with the original data, relevant theory, and the conclusions being drawn. So number one, you ask yourself if AI output is credible, dependable, and confirmable. Number two, AI is a confident liar. Treat every citation and specific data point as a hypothesis that requires manual verification. Number three, AI excels at patterns but struggles with thin data. Your judgment identifies contextual nuance or where the model has smoothed over critical niche academic tensions. And number four, ask yourself if the output reflects the data provided or is it merely echoing the bias of its training set. Another important skill is task decomposition. This is the practice of breaking complex research tasks into smaller, manageable steps. When AI is asked to perform large, multi-stage tasks at once, it may lose focus or produce unreliable output. Instead of relying on a single prompt, researchers can create a sequence of linked instructions. For example, a model may first extract relevant data. That step is then reviewed for accuracy by the researcher. Next, you prompt the model to categorize the information, followed by another review by the researcher. Finally, it synthesizes the verified categories into a summary. This stepwise process transforms AI use from an opaque shortcut into a transparent research method. By decomposing tasks, researchers can identify where mistakes occur and correct them early on. This is an example of prompting the wrong way, followed by a more effective decomposed method. So the decomposed method provides clear direction to the AI and does not leave room for drift, which is the place with AI where mistakes often occur. Everybody get a chance to read that? Good. The workflow integration skill means working AI into existing practice rather than treating it as a separate task. The goal is to create a structured partnership that improves efficiency without reducing rigor. The associated augmented pipeline process can be understood in three phases. Phase one is preparation. During preparation, AI can assist with organizing materials such as sorting PDFs or structuring notes. Phase two is execution. During this phase, structured output methods support large-scale data extraction and processing. And phase three is review. This is the phase where human expertise is applied to evaluate accuracy and interpret results. Effective integration allows researchers to increase speed while maintaining scholarly quality. Over-automation is never the goal. The Pareto principle, often called the 80-20 rule, suggests that a large share of results come from a smaller portion of effort. AI can manage much of the repetitive work, such as sorting data, formatting materials, and performing initial extraction, tasks that usually require significant time and manual effort. AI may organize the information, however, the core of the scholarly contribution lies in researcher interpretation, contextual understanding, and theoretical insight. Using AI to save time does not mean reducing intellectual effort. Instead, it allows researchers to invest more energy in analysis and writing. When judgment and synthesis are fully delegated to AI, the work risks becoming mechanical rather than scholarly. Maintaining this balance helps ensure that AI remains a research assistant while the human researcher continues to lead the inquiry. The above is an example of how the 80-20 rule might work. The standard workflow is how we did it before AI. Much of the time-consuming tasks can now be outsourced to AI. The integrated workflow is more efficient and allows the researcher to focus on more complex tasks of synthesis and analysis. Next up is the skill of iterative refinement. Iterative means relating to or involving repetition, specifically a process of repeating a sequence of actions, steps, or cycles to improve a result or move closer to a goal. Rather than aiming for a perfect final result initially, it involves creating a version, gathering feedback, and adjusting based on insights to continuously improve. This can include brainstorming and conversation. The process itself is nonlinear and cyclical. It uses discovering and testing as a method to refine information, and the method is repeated through interaction with AI. Iterative refinement is the conversation where the real work happens. This process involves never accepting the first response. Think of it as a critique loop. You give an instruction, look at the result, and then give the AI formative feedback. You are coaching the model towards the exact level of depth your research requires. You're essentially mentoring the AI and building reliability through thoughtful engagement. When you work with AI in this way, the result is often a more polished, high-rigor product that aligns with your specific academic voice. The frontier recognition skill aligns with the jagged frontier concept. This critical skill involves identifying when the model is operating within areas of strong performance and when it is entering a high-risk zone. For example, AI may effectively summarize a long document that has been provided as input. However, when asked to verify an older citation, the likelihood of inaccurate or fabricated responses increase. Effective collaboration requires knowing when to rely on the model's efficiency and when to apply manual review or independent verification. As a general guideline, tasks that require complete factual precision should not be fully delegated to AI. Maintaining awareness of these boundaries helps researchers use AI strategically while protecting scholarly integrity. When working with AI models, being flexible in your methods is the most advanced skill. So the real skill is not knowing which mode to choose, but when to be flexible. So up to this point, we focused on the conceptual model and the core skills needed to work effectively with AI. Now I want to shift into practical research methods that make those skills operational in real workflows. We're going to discuss some structured workflow concepts, including prompt chaining, retrieval-augmented generation, or RAG, evaluation, and structured output. The first concept we are examining is prompt chaining, which is a method for managing complex research tasks by dividing them into smaller sequential stages. In this approach, the output from one step becomes the structured input for the next. Chain of thought prompting asks the model to work through something step by step. This creates a more visible reasoning path that researchers can inspect and evaluate. This is a method of making the AI show its work. Rather than asking the model to extract, analyze, and format a data set in a single request, researchers guide the process step by step. For example, the first stage may involve extracting relevant data using clearly defined parameters. After reviewing and saving the results, the researcher reintroduces the verified material for the next stage, such as analysis. A final stage may focus on synthesis or formatting. This structured sequence treats AI as a collaborator, assigns specific responsibilities within a larger research design. By controlling each stage of the workflow, researchers maintain transparency and reduce the risk of error. This is an example of chain of thought prompting. With a standard prompt, there's a high probability of error or hallucination. The clearly defined chain of thought prompt assures a higher level of rigor. So if you look at the difference between these two prompts, you can see how that second prompt really gives it a guideline that it can follow. Concept 2, retrieval-augmented generation, or RAG, is a method used to improve the reliability of AI-generated responses. Instead of relying only on information learned during training, the model retrieves relevant material from trusted sources, you in this case, before producing an answer. This approach helps reduce fabricated or outdated information by grounding responses in specific data sets. In research contexts, this often involves providing the model with uploaded documents or curated knowledge bases and asking it to generate results based on that material. By anchoring AI output to verified sources, retrieval-augmented generation supports more accurate and context-specific analysis. Concept 3, evaluation, is an essential part of effective AI use in research. No single model performs best across all tasks. Researchers may need to compare outputs across multiple systems to determine which provides the most accurate or relevant results. By reviewing responses from different models, researchers can identify patterns, detect inconsistencies, and strengthen confidence in their findings. This process is similar to triangulation in research methodology. Model selection should be guided by task requirements such as depth of analysis, domain specificity, or reliability of citation support. There are a variety of models out there available for research. You aren't solely reliant upon the bigger models, though they can be useful as well. And I do have these models and resources that you can look at later. Concept 4, or structured output, refers to generating AI responses in predefined formats such as tables, coded categories, or data fields. This approach shifts AI use from narrative summarization through systematic data extraction. For example, unstructured sources such as interview transcripts, archival documents, or open-ended survey responses can be converted into organized data sets. Instead of producing a general summary, the model formats information to align with existing spreadsheets, coding frameworks, or database tools. By requesting structured output, researchers reduce the need for manual cleaning and post-processing. You might think of the method for obtaining structured output as similar to a digital fill-in-the-blanks form. You provide the fields, then provide your raw text or documents. The AI extracts the information based around the specifics you provide and will ignore irrelevant text. This is an example of the raw data as it normally appears in qualitative research anyway. A conversational paragraph that is rich in detail, but difficult to compare quickly across multiple subjects. You might have 100 of these. This is an example of a prompt you might use to obtain structured data. By telling the AI to act as a research assistant, it sets a professional tone and focuses on accuracy. It lists the specific variables, or the schema, so the AI doesn't have to guess what is important. The instruction to not include conversational filler is what forces the structured output, ensuring you don't get a long paragraph explaining why the AI chose these answers. You can use this exact same prompt for 100 different interviews and get 100 identical tables, making the data collection perfectly consistent. This is the after structured output. By using a predefined template or schema, the AI ignores the conversational fluff and extracts only the specific variables the researcher needs. The output from the blueprint prompt will look something like the table here. This data can now be exported directly into a spreadsheet or database. This is example 2 of the blueprint strategy applied to a literature review. By listing specific categories 1 through 5, you're creating a digital mold that forces the AI to be precise and consistent across hundreds of papers. By telling the AI what role to play, e.g. in a research assistant, you prime it to look for academic rigor rather than general summaries. No introductory text is a crucial directive for data cleaning. It ensures the output is ready to be pasted directly into a master spreadsheet. This same prompt can be reused for an entire semester's worth of reading, turning a mountain of PDFs into a searchable database in minutes. So why does structured output matter for research? If you have 500 student essays, the AI can read them and instantly extract specific themes, grades, or keywords into a consistent format. It ensures the AI never forgets a category. If you ask for participant ID, sentiment score, and primary theme, the AI is forced to provide all 3 for every single entry. In standard AI interactions, the model might wander or add chatter. Structured output locks the model into a rigid digital mold, ensuring the results are ready for statistical analysis. You might think of this in terms of professional workflow. You first collect sources, provide those sources to your model of choice, use chain prompting to gather data insights, and then export tables or data sets. Then the human element comes into play with the review synthesis process. So at this point, we shift from techniques to collaboration. AI systems are particularly effective at producing large volumes of information, identifying patterns, generating simulations, and supporting drafting or literature exploration. These capabilities can significantly increase the efficiency of research workflows. Human researchers contribute differently but equally essential strengths. Creative reasoning, contextual interpretation, strategic thinking, and ethical judgment remain central to scholarly inquiry. Effective research practice emerges when these complementary abilities are intentionally combined. Rather than viewing AI as a replacement or a simple tool, it's more useful to understand it as a collaborative partner. Productive partnerships build on the strength of both human insight and AI capacity to support innovation and more rigorous outcomes. Humans act as the principal investigator and AI as the research assistant. When we talk about collaborating with AI in research, it helps to think less in terms of using a tool and more in terms of directing a process. In this environment, the researcher's role begins to resemble that of principal investigator. Rather than performing every procedural task manually, the researcher defines the structure of the work, oversees execution, and evaluates outcomes. For example, tasks that once required many hours of mechanical effort, such as organizing large volumes of qualitative data, can now be delegated at an initial stage. The researcher sets the parameters, the AI performs the first pass of organization, and the researcher then audits and interprets the results. The shift does not remove responsibility, it clarifies it. AI may provide scale and speed, but scholarly judgment, methodological transparency, and final interpretation remain human obligations. In practice, researchers often work with AI in different ways depending on the task. Rather than follow a single approach, effective collaboration involves shifting between distinct modes of interaction. These modes are not mutually exclusive. A researcher may use one approach during early exploration and another during detailed analysis or writing. The key skill is recognizing which mode best supports the goals of a specific stage in the research process. The Centaur mode is about intentional delegation. The researcher maintains conceptual control while assigning bounded execution tasks to AI. This approach works well when accountability and methodological clarity are essential. In Centaur collaboration, the human and AI roles remain clearly distinct. You retain responsibility for research design, interpretation, and final judgment. The AI supports mechanical or time-intensive processes such as transcription, formatting, or initial structuring of data. For example, you might conduct interviews and develop analytical insight while the AI organizes transcripts and decoded tables that you then review and synthesize. Unlike Centaur mode, where responsibilities are clearly separated, Cyborg collaboration involves more fluid boundaries that evolve as the conversation develops. Cyborg collaboration involves ongoing dialogue between the researcher and the AI. In this mode, the system functions more like a thinking partner than a delegated tool. Rather than assigning tightly bounded tasks, the researcher engages in conversational exchange to explore ideas, test interpretations, and refine emerging arguments. This approach is especially useful during early stages of research when questions are still forming. Continuous interaction allows new perspectives to surface and support creative exploration. In Cyborg collaboration, the boundaries between human reasoning and AI contribution become intentionally more fluid. This mode can be especially useful when developing theoretical arguments or evaluating competing perspectives. For example, a researcher may draft an initial claim and then ask the AI to generate counterinterpretations based on selected readings. The researcher evaluates these responses, adjusts the argument, and may request support in clarifying language or strengthening structure. This exchange can extend cognitive reach and stimulate creative insight. When comparing these two collaboration modes, the key question is not which is better, but which fits the needs of a specific stage of your research. In Centaur mode, responsibilities are clearly separated. The researcher maintains conceptual control while assigning defined execution tasks to AI. This approach is especially useful for high volume or procedural work where efficiency and documentation are priorities. In Cyborg mode, collaboration becomes more interactive. The researcher engages in ongoing dialogue with the system to test interpretations, refine arguments, and explore alternative perspectives. This mode can support deeper insight, but requires sustained critical oversight. Ultimately, the responsibility for interpretation, methodological transparency, and final decisions remains with the human researcher. Cross-platform triangulation with artificial intelligence is a research strategy that uses multiple AI models to verify data. This is a safety measure against error and bias. With cross-platform triangulation, AI outputs are treated like sources. An output from one source can be given to other platforms and tested for accuracy. You look for both agreement and divergence. The goal is to compare reasoning, not answers. This visual shows cross-platform triangulation in action. Instead of trusting the output of a single AI system, we run the same task through multiple model architectures. Each model has been trained differently and tends to make different kinds of errors. So when the outputs agree, our confidence increases, but when they disagree, that's not a failure. Disagreement tells the researcher exactly where to slow down, investigate sources, and apply expert judgment. Rather than replacing scholarly rigor, AI can strengthen it because it makes uncertainty visible. The black box is the lack of transparency in how AI works behind the scenes. In academic research, we do not trust outputs that we cannot audit. A black box AI response may look polished, but it hides the reasoning process behind the conclusion. As researchers, that creates risk because we cannot fully verify how the information was selected, interpreted, or synthesized. The goal of the missing middle strategies is to force transparency. We want the AI to provide digital receipts, That means visible reasoning, structured evidence, and traceable links back to the original data. This will ensure the logic of the analysis is defensible and reproducible. When researchers rely on black box summaries alone, they weaken methodological rigor. But when we design workflows that expose the AI's reasoning and evidence, we strengthen credibility. On the left is the black box, which reflects the most common way people use AI. A broad prompt goes in, a polished summary comes out, but the logic behind the output remains hidden. On the right is the glass box. This is where missing middle strategies change the workflow. We're not changing the AI itself, we're changing how we direct it so the output becomes more transparent and easier to audit. 3 methods make that possible. First, chain of thought creates a visible reasoning path that researchers can inspect. Second, structured output turns vague prose into organized, inspectable data. Third, RAG and citation grounding tether claims to specific source material. Together, these strategies shift AI from opaque convenience to methodological rigor. Moving from the black box to the glass box means moving from passive acceptance to active verification. Let's talk a bit about the ethical trap that may come into play with using AI in research. AI used correctly is not cheating, but a research tool that can be used to perform ethical research, brainstorm, triangulate, and perform peer comparison. There's a difference between asking an AI to write your paper or collaborating with an AI on research. Efficiency is the goal, not automation. Ethical use in AI research requires transparency and data protection. Researchers should document AI assistance in the same way they report the use of analytical software. If AI contributes to literature organization, data preparation, or interpretation, this involvement should be acknowledged within the methodology to preserve a clear scholarly audit trail. Equally important is the protection of participant confidentiality. Unless researchers are working within secure, institutionally approved systems, they should assume that uploaded content may be retained or used for future model development. Identifiable or sensitive data should therefore not be shared with public AI platforms. Responsible use involves balancing innovation with established ethical standards for privacy and research integrity. Algorithmic bias is an important consideration in AI-assisted research. AI systems are trained on large bodies of existing content, which may reflect historical inequalities or dominant perspectives. Without careful oversight, this can result in analyses that oversimplify or obscure the diversity of participant experiences. Researchers can address this risk through critical review and methodological triangulation. Comparing outputs across tools and returning to the original data helps ensure that findings reflect complexity rather than algorithmic generalization. Maintaining academic rigor and ethical standards requires final human review of AI-assisted work. Researchers remain responsible for verifying sources, confirming accuracy, and ensuring appropriate scholarly interpretation before publication. AI can support data processing and organizational tasks, but the originality and intellectual contribution of research arise from human synthesis and critical judgment. Viewing AI as a collaborative support tool helps preserve methodological integrity while allowing researchers to benefit from increased efficiency. As we conclude, let's return to the idea of the missing middle. AI use in academia is not just casual prompting, and it's not advanced programming. The real skill here is strategic orchestration, knowing how to design workflows where you remain the principal investigator. Throughout this session, we've explored practical ways to do that. When you assemble context and use retrieval methods, you ground the AI in evidence rather than opinion. When you request structured outputs, you move from polished summaries to inspectable data. And when you understand the jagged frontier, you can intentionally shift between Centaur delegation and Cyborg collaboration, depending on the task. The purpose of these strategies is not to remove the scholar from the process. It's to offload repetitive labor so you can focus on interpretation, theory, and meaning making. As you leave today, don't think of AI as a tool that you simply use. Think of it as a system you manage. Build your methodological blueprints, triangulate your findings, and remain the final authority on your research integrity. The missing middle is not a gap, it's where your most rigorous research begins. Any questions? We have a couple of minutes, I think.
I have a question that's, I think, to everyone, which is, in the journals that you publish, what are the rules about using AI? I mean, I've seen some journals say very clearly no AI at all.
Yeah.
So I just wanted to hear, like, what are people seeing? Are they seeing, like what you said, you can use AI as long as you explain how you used it? No AI? You know, what are the range of policies that people are seeing in journals?
Well, I think right now that most journals are saying no AI, don't use it at all. But that's going to change over time. And I think when we look at it through, the lens of what I just presented here, the missing middle, and we help them to understand that it can be used as a tool, as a collaboration tool, that's going to change. But
Do you have publications with AI?
well, I do, but not in journals. No, that has not happened with me yet. Yeah, but I expect over the next year that's going to change. I think. What do you guys think?
I'm wondering how so if I can play on this, like IEEE and a few others, they give specific, like this is how you should cite it. Like some of these, how would you say this is how I used it? Like,
Right.
You might not use it for the ideation, but you might use it for the data gathering and summary, right? So would you somehow in your article journal say, I used AI and this is how I used it, and then like link to something where you actually have the original raw data along with the prompt?
I think you would cite it just like you do. So let's say that you used ChatGPT 5.3 model, right? So you would probably cite that as ChatGPT 5.3 model, whatever year that model came out. And then from there, I think it would really depend on what that journal is allowing you to do. I mean, if they say that you can use AI to just for, say, in Centaur or Cyborg mode, maybe as a collaboration tool. I talked with it, I think though what would be important would be that you have a trail, right? So you would need to use it in a mode that is.
I actually want to try to help answer this question. I mean, there's this kind of the credit standard of authorship, right? Where every author gets attributed to different aspects. I assume you could just apply that same authorship to an AI, right?
There you go. That's a good.
It's already an existing standard for co-authors. To me, it seems like that same standard could be applied to an AI to do the data analysis.
What's it called?
A credit authorship standard.
And these are things we're sort of working out now too, right? But I think when you use AI, you have threads, right? So you might want to name your threads by a specific name. You might want to keep those very organized. And when you cite it, maybe you say GPT, whatever it is, and then you have that name of that thread as well. And, you have that trail that you can go back to. You keep it in a professional, you make sure that you, like now what they have with the GPT model anyway, I'm not sure about Gemini or others, but they have an area where you can have a project. So maybe if you kept it in that project area or something along those lines. But those are all things that are kind of, we haven't quite figured out yet, because as it is now, like I said, most of them just won't let you use it. They're saying, no, don't use it. But the fact is that what you do is you create a shadow usage. People are still going to use it. And so I've got 3 minutes, but people are still going to use it regardless of, and then they're just not going to cite it. So, I mean, at some point, they're going to have to, relax a little bit on that. Any more questions?
At what point do you think AI will be the main usage of, like, how far into the future that you think AI will be widely used? Do you, in your opinion, think?
Well, I think right now it's widely used in many contexts, but I don't think in academia it's being used so much.
Or accepted, I should say.
Accepted by, yeah, humans are a little slower at acceptance, but maybe the next few years. What do you guys think? A few years, 5 years, 10, maybe 10? In academia, maybe what, 15, 20?
Never.
Never, maybe never. But generally, it's becoming much more popular. Like I said, what I was shocked with finding was that teenagers reported they use it for all of their homework. All of their homework? Okay, I don't know what we're learning there. That's not good. But so there's a lot to be worked out at this point. But you know, in general populace, 5 years. Yeah. Think? I don't know. It's just my opinion.
My question is, when will AI be doing our jobs and we won't be necessary?
Right. Never. I'll tell you never. And because I work with AI a lot, and it's, you know, they like to hype it, but it gets stuck. It gets stuck in a lot of areas. And I think that's got to be worked out.
Well,
You know,
someone's got to check their work. AI does work.
exactly. Exactly. We have to check their work, which is when we have to check this supposedly perfect, I don't think it's taking our jobs anytime soon. I wouldn't have said that a year ago. A year ago, I would have said that it would, but I've worked with it a lot more. Well, maybe 2 years ago, I would have said that. But I've worked with it a lot more since then, and I can't see it happening anytime soon. So we can hope. Thanks very much.
Thank you.